What is 5 megahertz frequency band for Wi-Fi or for wireless LAN? So like we discussed previously in the previous video about 2.4 gigahertz, that it gives us total 14 channel and 3 are usable. What are their ranges? So let's discuss about 5 gigahertz. 5 gigahertz, it has been arranged a little bit differently as compared to 2.4 gigahertz, and that's the confusing point for most of the students. So 5 gigahertz total, these are bands and these are combination of bands actually. So if we see the whole distribution of all frequency ranges or channels in the 5 gigahertz band, we can see that totally these are 45 channels, right? But if we see the standard 20 megahertz channels, then these are total 25 and 24 out of it is usable. Usually we say that okay, we have 24 channels. So in the interview, if you are asked that how many frequency bands do we have in 5 gigahertz, the first answer should be 24, but you should remember that these are total 25, right? So 3 out of these are further reserved in some countries which are called as TDWR. These are usually for radar and all of those kind of communications. So each channel width, like 2.4 megahertz, 2.4 gigahertz channel, each channel width is 20 megahertz, which means that this channel number 36, it will start from 5170 and it will go up to 5190 megahertz, which means it is 20 megahertz wide, not 22. Usually we go with 20, right? And channel number, it starts from 36, 40, 44, 48, and it has been divided into 4 groups which are called as unlicensed National Information Infrastructure, group number 1, number 2A, number 2C, and UNII number 3. So totally 4 groups we can say generally, right? And these are the frequencies from where each group starts and where it ends. So here we have, if we see in terms of 20 megahertz standard channels, then totally we have 25 channels. So channel number 36, 40, 44, 48 and onwards up to 165. But like I said, that the channels can be combined because somewhere it might be requirement, because since we have enough space, so why don't we combine two small channels and make a one big channel of 40 megahertz. So we can combine channel 36 and 40 and we can make a big 40 megahertz wide channel, which is channel number 38. Similarly, so these are all the combinations. Then further we can, if there is a requirement, because we have enough space, we have enough frequency band, so we can combine 240 megahertz and make 180 megahertz as well. So this is also an interview point, that can we combine 2 channels and make 1 channel in 5 gigahertz? So we can say yes, and it is common routine. And when you go to your Wi-Fi router configuration in our lab part, I have also created a practical lab for you guys in which I want you to configure Wi-Fi yourself, install Cisco packet tracer simulation software, and over there you have to go with it, right? With the installation, configuration, and then the devices will be connected. So over there you will see all of these configuration, you will see when you will be doing with your own hands. So it's very important to do that lab. I'll give the lab part, the topology, wireless topology, packet tracer topology, and the PDF lab manual. You guys can do it yourself so that you will have more idea about frequency bands. So over there you will see that some router models, they give you a provision to choose the channel width. So if you choose 20, it will show you total 25 channels. If you choose 40 megahertz, it will give you less number of channel. If you choose 80 megahertz, it will give you only 6. If you choose 160, it will give you only 2 options, right? So this is the arrangement. While this was not possible and it's not common routine in 2.4 gigahertz. So your answer in the interview should be no, and it's not. Although we can combine, theoretically can be combined, not a problem, but we are already struggling with frequency channels, non-overlapping channels in 2.4, so it's not a good practice to make this frequency unavailability problem more severe. So we directly use them, and there is no need as well, because these are low frequency channels, they can travel long, so why should we need more channel width? But here, since the frequency is high, data rate is high, but it cannot travel longer, and then some other modulation issues as well, which I don't want to go into much detail. In the next videos, we will go into much details about OFDM, about DSS, that how it affects the channel width, but it will be too technical. So multiple channels can be combined together. So the frequency bands have been divided into 4 groups, and these are the frequency ranges. Another important point in 5 GHz band is that there is no space. In 2.4 you could see that there was a space of a small space between the channels, right? Co-channels, adjacent channels, a 5 MHz space. But here we don't need space because they are not overlapping, right? So you can see here the first channel, channel number 36, it starts from 5170, goes up to 5190, and immediately after 5190 the next channel is starting. So between the end of 36 and start of 40 there is no space, right? The space is also not here, but it's a little bit of cushion, a little bit of buffer, so that the next channel can move further. But here it's not needed because they are not overlapping with each other. So this is all about 5 GHz frequency band. In the next videos, we will discuss about Wi-Fi signal strength, and then as we move away from our Wi-Fi, how the signal strength decreases and how we can increase it. Some of the methods practically, like if you are using a Wi-Fi router at home, how can you increase its range? So now it's questions time in the end. Again, I'll ask you one question. Please write your answer in the comment section below. So which Wi-Fi band covers long range? Is it 2.4 GHz channel band or is it 5 GHz band? Which of these gives you long range? Please write your answer in the comment section. Thank you for watching.